In section 2.3, we're going to discuss some basic facts about limits and use these four basic facts to derive other properties of limits. The first basic fact that we want to discuss is what is the limit as x approaches a of some constant function? Okay, so let's just think about it from the graphical view. Well, if I draw a constant function, that's a horizontal line, and it doesn't matter what value of a I pick to evaluate it at, I'm always going to get the constant value. So the limit as x approaches a of a constant is just that constant. The second basic idea is the limit as x approaches a. What does x approach? Well, let's draw the identity function. Well, the identity function is a memorized graph. If I put a into the function, I will get a out of the function. So the limit as x approaches a of x is just a. What this tells me is that, hey, if I have the limit as x approaches 2 of x, as x approaches 2, what does x equal? Well, it actually equals the 2. The next property that we're going to use to derive all of our other properties, it says the limit as x approaches a of the sum of f of x and g of x. The actual property says that it's actually the limit as x approaches a of f of x plus the limit as x approaches a of g of x. One way that you can interpret this is that the limit of a sum, which is the left-hand side of the equation, is equal to the sum of the two individual limits. Similarly, if I take the limit as x approaches a of f of x times g of x, that is equal to the limit as x approaches a of f of x times the limit as x approaches a of g of x. In words, it says the limit of a product is equal to the product of the two individual limits. In the next video, we will use these four properties to come up with other properties that will make finding limits of functions a lot easier for you.